out too well, so we're trying this again. All right. So, I made a definition of my unity of unity would be. It would be on the same 1, 2, 3 as normal operation. So, I believe it to be, you have to have a source in order for your operation to work. Then if there's no work, then it's not going to work. And if it does, man, you got to show me. I'm not going to listen. I'm not going to listen. I need to see it. I really do. But over unity, it means that the source battery charges in a closed loop system. One battery, the same battery as the blower. So this battery charges the closed loop system. See, so what I suggested is, the reason why people don't see over unity in a closed loop system is because we don't have batteries to do that. And some people say we do, some people say we don't. I don't know either way. I know that every single time I set one up, it's normal operation. It takes a while for it to go down, but it goes down. normal operation is the battery value and voltage goes down. That's normal ops. So it's going about 800 right now. That's with the 2 on from the T energy batteries. So I say it goes between 2,000, 1,500 and 2,000, pretty much guaranteed. So I was talking to an old friend a long time ago about goals that I wanted for my rotors. We came up with 5,000 for an end goal. For a rotor that will go 5,000 without falling off the wheel, or just goes 5,000 runs at 5,000. So I kind of put that aside, but I think I'm going to pick it back up again. I did put it down. Definitely want to give that another shot. See if I can get this to go around 3,000 RPMs. So when it starts shaking, it's literally going about 1,600 RPMs. And at that point, it's still accelerating extremely fast. So, yeah. Usually I'm like right around, right here, and I gotta reach over to stabilize. It's going 500 right now. 450. Yeah, man. I don't know if 6.5 milliamperes is a lot, but each one of the dual drives has 6.5 milliamperes in it. Inductance. So I would say that's low. But I don't know if it's not normal. I think it is normal. See, I got 1 pound and 24 right now. I'm working it in. I want to do, it's not enough copper to do 1 core. Based on what I hear I need to be. So I'm actually going to have to go 3 pounds, 3 or 5 pounds of 24 to make a decent coil, decent uni coil. So I don't know what you would call these coils. They're really, yeah, they could easily be coiled right now with 50% box. But I think they're doing the job pretty dang well for what it is. I'm going to step it up. I'm going to want to get the coils to be around yay big, a little bit fatter than this one, and all bi-firing. This is a 4-firer coil with 2 drives, 2 triggers. Run together, like 1.8, 1.5 times. It's not 2 times better, it's like a little bit less. But it is better than just running it alone. There's a lot more torque, there's a lot more power to it. Definitely more torque, man. Everything happens faster. You get to where you're going, but you get there faster. When you're going, it could be 5,000 RPMs, but if you get there, it takes you 2 days to get to 5,000 RPMs. Throw that away. You know what I'm saying? Throw that away. It's not practical. But what you can do is put a time, maybe a smart goal. put some time, restraint on how to, whenever you start taking measurements, I like to take measurements from the start. So it's like, however, 0 to 60, that is prime time for me. Okay? But a lot happens for me in that time. These little coils, man, that do stuff. In that time, you are not going to get from a big coil. And, the bigger, the more power you need to put into the big ones. And that's cool. I mean, I've done some 24 volt work. I'm just enthralled. Beautiful rotor. And yes, I agree 100%. You can see it working, and that work never stops. And you can probably have more unity without the battery actually charging. You can do, I guess you can do what we would call a mini loop that does not include the source power in it. Okay, so this mini loop runs on itself, or it's supposed to, but it's connected to the source power through a on-ramp, so to say. I can see that as being a thing. Having like a mini loop inside of the loop system. So you can just, and the system will only take from the battery what it needs, and if it doesn't need anything, it's not going to take from the battery. That might confuse you to start and say, hey, man, it's just not moving. But yeah, once that keeps moving, I'd say that's good. That's gold. For sure. But, if it's going to be what I've set up, a closed loop system, with the battery being part of that loop, it can't happen because the battery's not sophisticated. If you're monitoring the battery to determine what it do, fail all the time. I see it all over the place, but, through amplification and, certain things, it all makes sense within the parameters of what's real. You know what I'm saying? It all makes sense. There's nothing that goes beyond what's real. It's all real. Okay? Call it free, perpetual motion. Now, perpetual motion is something that I need to see. I think I see it all the time, but I don't know. For sure, I know I don't see it all the time. I set up a relay that was pretty close to unity. So I was thinking about running another pulse motor off of this DC cap amp right here. I don't have enough clips to set that up. I have to buy more clips. I have to learn how to solder overnight. And it's like, I don't know. I don't know. It's like the temperature must be pretty important, right? Yeah. Wow, like that is so not important, dude. Sorry, I don't. You don't want me to get into that because I'll tell the truth. I have a very bad tendency to tell the truth. Good thing, in my opinion. Quality. Dan and the hand. All right, Dan. Oh. That is awesome. Woo. Yeah. Yeah, man, this is not a policy. All right, take this off of here. All right, so that is my Utron rotor. This is my workbench. Been charging these two batteries with two of these coils for a little while.
The Utron is a 4-magnet rotor. It's got 4 neodymium cubes on the inside, south facing out, north facing in, which creates a north bubble, which floats the Utron on those mags down on the bottom. Now, I'm debating as to whether or not I'm going to print stands for the coils. And I might do 45 degrees too. Instead of just 90 here, I might do an offset one so that it'll be pounding at 45 and 90 degrees. That'll be sweet. Why do that? Because why not? Why not? What? What? What the? Everybody here is accountable for what they say, right? You are the man. I love you too. Thank you very much. So, what I was debating on is whether or not I should put coils at 45 degrees as well. How are you, Omar? This is an Utron. It's a pulse motor. Each one of these coils is parallel. They have each one has its own power supply and its own load. Um, there's 4 magnets in the rotor, if I haven't said that. So they're at 90 degrees, and so each time one of these coils hits, the other ones are hitting as well. So we get lots of torque, lots of speed. But I was thinking about having an offset coil. Each one of these coils is 400 turns of 24 on this 180 and 32, 24 and 32 right here, and 22 and 32 right here. It's well, it is resting on a magnetic field too. It's mag left. And then, yeah, it rotates because of the magnetic field um, when I turn it on. It's got minor flywheel capabilities, and I mean minor, like extremely minor, but it's so well like balanced that it'll spin for a while. Uh, I would say yeah, through resistance and variable resistors, you can adjust the speed, and through voltage input. But you want to adjust the voltage input equally across all your coils. So I'm at 12 volts right now, and it is too fast, way too fast. But I can, knock it down to 9 volts, but then these 2 battery packs will be too much, and I'll need a potentiometer to reduce the voltage. But I could do that. Yeah. Yep. Yep. Over across all 4. You want to keep it as balanced as possible, or your shaft is going to start to vibrate sooner than you want it to. My brother has arrived. Here we go. Thank you, sir. All right, I'm gonna put this back up on the tripod. I'm gonna try and get this rotor going real quick. check that. That's good. We're a little far away, but that's okay, I think. Hopefully you can hear me through the headset. Provides a microphone. I hope it works. I'm not sure if it's working. This.
I think his name is Gerald. He's in the house.
Hey Gerald, what's up?
And like, true.
Yeah, that's good. Hey, what's going on?
He said, all right, now this is cool.
These little coils pound. They're amazing. 400 turns a piece.
It's a little far back. I'll zoom in a little bit. There we go. All right.
So this is pounding equally on all four magnets at the same time. Actually, it's only pounding on two. I didn't turn the other two drags on. That's why it took so long to heat up too. So I let it cool down, and then I'll turn on both of these T-energy battery supplies for the other two coils, and we'll see some serious stuff. And then I want to have commutator plates. I was second guessing using copper though.
So
If
if you speed it up by hand and it goes faster than what the circuit can catch, does it slow down? Hold on. If you speed it up by hand, it will slow down to the same speed. Is that right?
I don't know, I think it slows down a little bit, and then I understand where you're going with the physics of that. Maybe.
Like a certain RPM where it can grab a hold.
Right, that RPM, yeah, I get what you're saying, the usable spin,
Yeah.
like,
And yeah, if you give it a spin, that's exactly what you
yeah, so if you start it from being, stopped like so, and then you turn on two, we're gonna do a full Monty this time, so I'll turn on the other two. And I'm gonna go to the other side because, three switches over there and then one switch is over here, so we have a problem. I'm gonna turn off the three first. Okay. So we'll measure that this time. It should be, you're right, it should be that way because of physics in the whole thing. All right, we're good. Good. Now one's on. That one's on. The other two are on. Woo! And that's very well balanced right now. We got the light, we're generating two batteries. And we got a cat bank that's on the third oscilloscope, or multimeter. Now, the circuitry, we got SSG with gen mode, we got SSG, and we got what I like to call the stem cell of SSG. You got an SSG basically without any resistance or any diodes to talk about. We got, except for the output on the stem cell ones, we've got diodes going to the battery and reverse diode to the negative of the battery. So it's utilizing both of the, you know what I'm trying to say, right? EMF and the back EMF or the continuation, I could call it, or the DD continuation.
The Bedini continuation.
So it takes
The boring continuation.
Yeah. It's going to become a movie
boring.
series. Yeah, man, that's so cool. And then this is just residual spin. I think it spins very well residually. So like if you were going to do something with AC, and try and do a closed loop system without a power supply, you want to do it with AC, because that would be where you get your energy from. But will you ever get enough to make it move? I don't know. I don't think you'll ever get it fast enough without source power to make a difference. That's why I think you would use things like graphene and other substances. So like when you move the magnet past the substance, all it takes is one brush and you've got enough power. Or whatever you're going to use to create that substance has got to like.
Oh, if you got, he says if you put like a stripe down the whole thing, we'll be able to see the speed better.
Okay. Maybe we'll be able to get a reading better too. Put it right on the seat. That's pretty straight too. It's not as straight as, but it's pretty straight.
There you go, leave it. Oh, it was still going. Let me zoom in a little bit on that.
Let's see if that works, if that's thick enough. It might not be thick enough.
I just walk in. There we go.
So I put forth the proposition
Got what I needed. Let me take.
about a closed loop, how you would measure unity and over unity in a closed loop. And I came up with, you have your normal reading, which is a loss in voltage in your source. You have the unity reading, which is no change in the source. And then you have the over unity reading, where your source is charging from your system. But now I'm learning that you can't have over unity if you use a source power because batteries aren't that sophisticated yet. Well, batteries aren't that sophisticated, you've got to create your loop, or whatever you're going to use, out. You can't have the source be in that loop. So, or it can't end and start at the source, where it would make sense to end and start at. But here, this is what you got to do. You got to have your source power feed a smaller loop. Maybe be drawing a PNP connection or some kind of connection where you're just drawing from the battery what you need to feed this loop. And the loop should be designed to not need the source power at all. That's how it should be. The source power should have an avenue to get into the loop if you need something from it. But if you design it right, it shouldn't need anything from the source power. except the initial start. And once you start it, you shouldn't have to ever take from the battery again if you do it right. How do you do it? I have no idea. And hopefully I figure something out with that idea. Like having the internal, like have it look like one of the talk bubbles. Like, you have the power be out here and have a little counter thing go in the loop, which would be talk. You get what I'm trying to say here? The source power currently cannot be part of the program. Permanently part of it. Now, I'm excited again because that sounds like it might work. As long as you got a system that will draw from the battery instead of using the battery like with the positive end, you use the negative end. And draw from it. They tell you to use a light to draw from it. Or use a motor to draw from it. Yeah.
Interesting.
And I believe it's a PNP circuit, but I believe what we can do is use a PNP, 2 feet an MPN, or the other way around.
I believe.
You can connect the two. You can use MPN to fuel a PNP, or the other way around. Or you can do both. But you gotta get it so it's just drawing power when it needs it, and then the whole rest of the thing will keep you moving. So the whole system will think that there's source power there, and there is source power there, so it'll function like there's source power there. But what's really going on is that miniature loop that's now will take the place of the source power. And that's what the whole idea is. But you don't ever disconnect the source power. You just make it have that little intro. There's no outro back to the source. It's just an intro. And and that energy goes around in the loop. Hopefully if you build it right, it should be able to maintain or drop in the battery very, very slowly. But I mean, if you build it right, then you should not have to draw from the battery twice. And I think when I put the other 4 coils on this thing, I'm going to put the other 180s at 45-degree angle. We'll have, I could make it so, we have, when it's off, it'll be off. When it's on, I can either make it pickup coils, or I could make it, 4 more parallel circuits. But I'm thinking that if I make it 4 more parallel circuits, I have to rethink it. I need to get more batteries. But it'll have the timing so that 4 circuits will be on and 4 circuits will be off all the time. And so when these 4 are off, 4 of the other ones will be on. So it'll be way better than it is now. And have way more torque, and it'll be hitting twice as much as it's hitting now. Of course, it'll be 2 times more coils, but it'll be at a different time. It'll be awesome. And what I'm thinking is that if we have these 4 have power supplies and the other 4 we put cap banks, we can start making that loop. Interior loop. And then, of course, you'll have each coil go fuel the circuit of the next coil. But when you do that, then everything stops. My hypothesis is if I do it that way, and I don't put these other 4 coils on a different pulse motor, it's going to stop. It's going to block down and it's just going to go. Because I've done something similar with one coil, using a pickup coil, and then I spun it by hand, and spun it with the motor and slowed down really fast. And I was using the pickup coil to power the SSG circuit. Okay, so it was completely legit, like if it was going to work, it was going to work fast. And what I did was, I turned the pickup coil into a big magnet, like almost a permanent magnet. So I don't know. Maybe I hooked up the diodes wrong, maybe there's something was hooked up not right. But I don't know. So my hypothesis is it could be a separate rotor shaft over here, it could be the one on the table right there. You put the 4 coils on that, and it shouldn't interfere with this rotor's performance. And we use one of these coils to power the cat bank that's going to run that motor. And you have your 4 pickup coils. And you got 1 coil down there that runs the motor. Now, see, we're getting creative, but I don't think we're there yet.
Getting creative.
We're getting creative, but I don't think we're there yet.
Got this.
Because there's no way that rotor down there is going to spin as fast as this one, so it should be a mirror image of what's going on here. And then, you got to think maybe this setup isn't going to work for that. That might be what happens. I need to get more cat banks. Yes. So we're going to have the power inputs, right? And we're going to have the outputs going in the cat banks. See, it doesn't work. Because then you have the source power mixed in with the rest of it. Well, I'll have to sit down and really consider how I would do this, because I know the pickup coils end up being a really heavy load. So it's probably not going to be with pickup coils, it's probably going to be with the beam extensions, collector, one of the cat banks. But I don't know, you gotta see here, and we'll have the common thing, like I said, the source power would go in to the loop, and then get trapped in the loop. And it would be a continuous feed, and that's why it's got to be built correctly. How to build it, I have no idea, but I know that currently, with the batteries the way they are, you have to do it like that. But you can't measure it. You gotta have something to measure. And I'm thinking motion would be a perfect thing to measure. It stops, get it wrong, keeps going, hit it right. So yeah. I'm noticing when you spin it, you get just the field is wide wider and wider, so you can have, all you need is one coil in there really tight to turn itself on, and then get it going, and leave these ones out a little bit. That's awesome, with the field, and I think old man Bill's like did his quadro rotor doing the same basic principle that's happening here, except on a much larger scale. So I don't think our line is thick enough to really tell. I need to put a fat line down. Probably what you said originally, a fat line. Now it looks like stitches kind of. Good there. There we go.
I got skin on my foot.
You can feel that moving through there, like, what happened? Well, you really can't see it. I like maybe draw half of it, cover half of it with black. Oh. Oh. Man, I just had a brilliant idea. So what we're going to do is we're going to take the battery and then we're going to feed the circuit, first circuit, and this first circuit is going to be the second circuit. The second circuit is going to be the third circuit, fourth circuit. I don't know, we're in the fourth circuit there. Connect to the second battery. Like that. Or we have the last circuit connected to the first circuit. And that would like make it seem like what I was saying is a possibility. I don't even think it's real. I'm just doing it because it seems like a logical way to make it work. If it doesn't work, oh well. Oh well. You know? But what we're going to do is we're going to take this, and this is going to power this is going to power that is going to power that is going to power that, this is going to go back in this circuit. And we're going to set up that battery so that the power is dropped. Awesome. But I'm getting pretty tired. I tried doing a screenshot. I took a shot of the moon when it was red the other night, and I used it as a screen.
Saw that. Nice.
People didn't get it. I'm like, okay. Was it the full moon today? Is that what it is today?
I think it was a few days ago.
Okay.
It might have, no, it was a couple days ago. It was smaller last week.
Okay, because I mean, we got some interesting individuals come up today.
On the chat.
Yeah.
Oh, wow. Let me look though. Hopefully. August 9th. Days ago.
Cool.
It's a ripple effect. Unfolding, reflecting, playing.
But I love the fact that when all four of them are on, all four magnets, it's a 4x4. All four magnets are pounding on all four magnets all the time. So it's like, well, you get this off phase right here, and that's why I'm going to add 4 more electromagnetic coils. And that's the bifilar ones. I mean, I make these 4 filer ones that are 26 gauge. And you hook them all up parallel. Woo! I got I call it the 0-1 pulse motor, the first one. The trigger coils are external. Right? Trigger coils. Then you have your 4-filer 26 gauge coil as you drive. And the offset trigger coil hits, oh my god, and they all pound at the same time. It's like quadruple, you get to where you're going so fast. And this is the rotor that I actually used. Okay. So nice. All right, so I'm going to rewire this to maybe do my loop. Let's see what happens. I think I'm missing something. I want to talk to Pete real quick about getting some of those plastic connectors that he uses, because I want to do a PNP to NPN circuit for the first one. Maybe for all of them, I don't know. And then these offset coils could be PNPs. Yeah, that sounds like fun. All right, but yeah, man, I'm running out of gas. This little coil is awesome. 168 ohms, 32 gauge. Works well as a trigger coil for the big rotor down there. And you know, it makes me wonder sometimes whether or not it's spinning under the influence of anything right now. But I don't think so. I think this is all residual spin. It's not spinning fast enough to electrify any of the coils because they're far away, but I don't know. It's taking a while to slow down or to stop on me altogether. So this thing goes so fast you can't see the line with it. But you can see it in the camera. I can't see it. Alright, we run this thing. One maybe they're doing it there. We're gonna call it for the name.
You can definitely see that line. That's a thick line.
I can't see it. I can kind of see it. Not really. Oh, it feels like really, really, really powerful when you look it up close. You can still feel it when I move it back this far. Just pounding. Oh, yeah. Woo! So I'd say that's right around 1,500 RPM when it starts shaking like that. And that's because the top of this thing rides really high on the shaft. So any minor thing goes wrong, you're gonna feel it. Especially because it's only a 1/4 inch shaft. That's awesome. I swear, dude, that's so cool. All right. Thank you very much, ladies and gentlemen. Peace out. Have a wonderful night. Thanks for tuning in, and we will get back to you. Thank you very much.
Thank you.